Everyone, Hugo Bound Anderson here from Vanishing Gradients and a few other things with Ravan Kumar from Google DeepMind and many other things as well. What is up, Ravan?
I'm doing well. Um,
Everyone, Hugo Bound Anderson here
oh,
from
I'm doubled up in the audio. All
I
right, folks. Yeah.
so great to have you here. I am doubled up on the audio as well.
Hey,
One
folks.
second.
As you're
Um,
watching, a lot of
I,
wires to hook
I
up to
think
get this up.
am I getting that from your laptop, Ravan?
Yes, although I don't have headphones, so this is going to be a fun one. I actually should have brought headphones.
Mute the YouTube tab.
All right.
I'm going to take my sorry everyone. Slight technical concerns. All right.
I think we got it this time. We're good.
One second. Something is coming from mine.
If you folks are watching, yeah, it takes more coordination than you think to set up these live streams. I unfortunately did not bring my headphones, which was a big miss. So hopefully you don't get duplicate audio from my microphone.
Um, so we're not quite. Is there still audio coming out of your laptop or is it mine, Ravin?
There's audio coming out of my laptop, but I don't have headphones, so there's going to be
Can
audio
you
coming out.
can you can you mute the YouTube tabs
The
that
YouTube
you have
tab is
open? Yeah, yeah.
that is muted.
I can still hear it though.
Okay, this is going to be
Can you
tough.
close all YouTube tabs?
Mhm. Done.
Great. Awesome. Just bear with us, everyone. One second. I have no idea where this audio is coming from. Sincerest apologies, everyone. Just bear with us 1 or 2 more minutes. Um, there's there's no audio from YouTube coming out of your laptop, is there, Ravin? Okay, it must be mine. Okay, I've sorted out everyone. Sincerest apologies. There are still, 30 people here, which is great, and we're about to get rocking and a rolling. But Ravin, great to have you here. And we recently taught a workshop on using local models such as Gemma 2 in order to build, privacy preserving local apps and those types of things. And then Gemma 3 came out, and we're like, wow, we need to do something to build agents, right?
That is exactly, yes. Right as we were doing Gemma 2 tutorial, I was working on Gemma 3 at Google. I couldn't say anything yet because we were just a couple weeks from releasing it, but we just released it a month ago. If I can say so myself, it is a model that a lot of people prefer. So if you took the that AI app basics course, you should go back and now install Gemma 3. It's going to work so much better. And if you didn't take that course yet, go back on Hugo's YouTube channel and go find it. All the code is online, uh, and you can just catch up.
Fantastic. And so we actually, one of the reasons this came about is because Raven gave a guest lecture at a course I teach on building software powered by LLMs that was just, people loved it so much. We thought to teach a bit more together, to be honest. And in fact, there's a cohort happening at the moment. And we've got a lot of people from that cohort here as well. So I just want to say what's up to all the wonderful people and highly sophisticated builders. We've got 70 plus builders in the course. Sharing a lot of wisdom and learning a lot. I'm learning a lot from them. I'm just going to put a link to the course if you're interested. We don't have any upcoming ones, but if you want to get on the wait list or something, do check it out. I've also linked to our Discord in the chat, and it would be great if we could have conversation there. It's easier to preserve than having it on a variety of different channels. We're doing it in a channel called Build AI Agents, Gemma 3 discussion that you should be able to find when you join the Discord. Very much appreciate you all bearing with us with audio fun. And just great to have you all here. So if you're introducing yourself in the Discord, let us know where you're calling in from. I'm in Sydney currently. Are you in the Bay Area at the moment, Raven, or LA?
I'm currently in the Bay Area, so
Awesome.
up north for me.
Awesome. And so we should just jump in, man. Do you want to share your screen, or should I? And we go through the README briefly, or
Yeah, let me go ahead. I'll share my primary screen and then I need a screen sharing
you got it?
permission. All right, we are ready to rock. Let me go through the README.
And I'm sharing the repo in Discord as well.
Perfect. All right, folks, train is finally going now. All right, so we are going to be going through the basics of AI agents. I'll say, Hugo, I'm a little bit worried that folks are going to be disappointed only because agents are so incredibly in vogue and hyped up right now. When you actually come and see what an agent actually is, it might be a little bit of separation between the hype and reality. But as Hugo and I like doing, we do tutorials where we show you everything that's going on. We don't hide anything up our sleeves. So you folks, if you're going to implement things yourself, you know what is happening. And if you're just in the AI space, you really know the technical details. So try for zero hype, 100% like content type courses.
Yeah, and one other thing we'll get to, I think, is, you know, agent is a marketing term, among other things. It is a useful term to think through the types of things we want to build. But essentially, as we'll get to, agents are LLMs that can do things. And how do you do things? You use tool calls or tool usage, function call type things. And how do you get an LLM to do that? You do it in a for loop or a while loop, right? So that's why if you've heard someone say agents are just LLMs with tool calls in for loops or while loops, that's what they mean by that. And that's some of the stuff we'll be getting to. But no, once you establish the basics of being able to do tool calls, that a lot more will follow from there. The other thing I'll warn people against is, and this is something we cover a lot in the course, and it's been really interesting, but brutal doing it this time because a lot of people want to learn like multi-agentic architectures. And like, I love frameworks like Crew AI, but you use them and then even figuring out what's up in your system is incredibly tough. And you need to build trust with your system. You need to look at your data a lot. You need to do error analysis. You need to load things up in spreadsheets. How do you do that with hardcore multi-agentic systems? You really need to start with bare bones, and that's what we're doing here. And I heard an analogy the other day that doing testing and evaluation for traditional software is like making sure the train is on the track and all the parts work, and then it goes, right? Whereas building trust and doing evaluation and figuring out how machine learning and LLM powered software works is more like driving in Midtown Manhattan at rush hour. Okay, where you're constantly evaluating, you're constantly maneuvering, you're constantly on guard, right? And I think that, all analogies break down, but I think that's useful, and that's why we want to build things from the bottom up as opposed to the top down.
That was a good one, actually. I'm going to steal that analogy, Hugo. I really like
Awesome.
that. So on that topic, we're not going to be driving through Midtown Manhattan, at least at the beginning. We're going to start by building a basic LLM app, which has tool calling in it locally. The reason we want to do this locally is so you folks can run it and try things out. You don't have to worry about rate limits. You don't need to have even an internet connection. And also, when you run things locally, you're able to inspect all pieces of the stack, and you can really dive deep into what's happening. So from that app, we're going to show sort of manual tool calling as we've listed here. The word manual in this case refers to we're really going to have to show all the different pieces of what it takes to make a tool calling bot from scratch again. And then the thing that's happened actually between the last time we started, Hugo and I had this course, and now is the whole MCP protocol has really picked up steam. And so we're going to show you how you go from the basic tool calling to MCP. And again, the reason we want to do that is so we layer in complexity one step at a time. So if you want to follow along, you can download Olama and the Gemma models. Hopefully you've already pulled them. This time we're going to be using one of two variants. I'll explain why in a little bit. So go ahead and activate the environment and start up your LLMs locally if you want to follow along with code. But you can also just watch the tutorial this time on YouTube, and we'll talk through it piece by piece. All right,
Exactly.
here you go.
And yeah, and so to start what we're going to do, if you scroll up just a bit, Ravin, yeah, we're going to start by building a basic LLM app locally, just to get a sense of how these things work. And then we'll start doing some agentic stuff with manual tool calling. And then we'll dive into the MCP and the model context protocol. We will be using Olama locally and Gemma 3. And one of the reasons we've suggested two different models. I'm not certain that my laptop at the moment, with everything we're streaming currently, would be able to use Gemma 3 12B. So I'll be using 4B, and Ravin will be using 12B, and so we'll be able to compare responses as well, which will be super fun. But I'm wondering, should I share my screen now, Ravin, and we can just
Yeah,
jump into
go
the
ahead.
first notebook?
Go ahead, grab it.
Awesome. And please do any questions in the Discord, everyone. Can you see VS Code, Ravin?
Not yet. Let's give it a second. I can see it now.
Fantastic. I'm just going to make sure that it's coming through on YouTube as well. Fantastic. Okay, so what we're going to do first, before building the actual agent, is we're not going to build models from scratch, as we know, but we're not going to use vendor APIs. We're going to download a local model, Gemma 3, it's going to be 4B or 12B, and interact with it through basic prompts. Then we're going to integrate a lightweight front end, just to get, so we can play around with these things. And it's nice to have front ends, right? And then we won't go through all of this stuff, but it's in the notebook in the previous workshop. You can integrate something like SQLite and Dataset, which is a tool Simon Willison has built for logging and observability. Always encourage you to do these things. But so you have a concrete idea of what we're going to take away from the first part of this workshop. You'll have a working MVP. You'll have a local chatbot with a UI, database for observability, simple, reliable architecture you can build on. And after that, we're going to build these on these foundations. I don't know how it's model context protocol. We'll create a basic agent and set up an MCP client and server to expose tools. Okay. So first, let's focus on getting Gemma 3 models running locally and understanding the building blocks of LLM-powered applications. So look, I love Gemma 3. There are lots of reasons to use it. It's, as you know, we all may know, it's a family of open weight models from Google DeepMind, designed for efficiency and strong reasoning capabilities. I've listed some key features here, Ravin, but I'm wondering kind of tell me about your vibe with Gemma 3.
So Gemma 3, again, just got released about 5 weeks ago now. They come in 4 different sizes. So 27B it actually is the most capable model that you can run on a single node per LLM or Chatbot Arena and other measures. So we're really excited about that. And then it goes all the way down to 1B, which you can run on a phone. I have a YouTube video you can find online about which Gemma size is right for you. It's about a 5-minute video, so it doesn't take too long to watch. And then most recently, I think about last 2 weeks ago or last week, if I remember correctly, we also released what's called the quantized aware version. So if you look at the models that Hugo put in, the QAT at the end means that they're models that have been compressed to about a fourth of the size of what's called full precision models, but they retain most of the capability. So they're even smaller on memory size than the full precision models, but they're just as good, which makes them easier to run on your laptop or places like that. So I'm a little biased, but I'm really, really excited about the Gemma 3 models, and independent of agentic stuff or MCP or any of that. I think they're really good models. I will also say that Simon Willison and others have been saying online that it's now their most favorite model to run locally. So I hope you give it a try, and I hope you like it as much as many other folks out there. Um, as Hugo said, that we're going to be using Gemma 3 for this particular course, which is going to be it's going to be real good.
Totally. And I just want to quickly jump into something else we'll be using. Let me know, Ravin, can you see my web browser with Olama?
I cannot see your web browser, Alana. I just see a VS Code.
Let me stop
Oh,
sharing and then,
no, yeah, you might be good. I realize the YouTube is a little delayed, but go ahead again.
um, great. I'm just trying. Yep.
There we
Yeah,
go.
no, I actually meant in the Zoom. Yeah, you'll see things in the Zoom before people see them in YouTube.
Yep.
So in the Zoom, can you see Firefox with Olama?
I Yes, I can.
Awesome. So we'll be using Olama, which is such a cool way to work with models locally. And one thing I wanted to jump, I mean, look at this. I got to search models, and it's rank ordering them in terms of vibe right now, which is super cool. But we can see Gemma 3, the current most capable models that run on a single GPU. Awesome. So we've talked, so you can go in and have a look at some things about these models, but you've got 1B, 4B, 12B, 27B. Now, Raven, the other day, I I think I overspoke, but I was like, how does anyone know what's what and what to use and what all these names are? And I think you've all done very well here actually, but I'm just wondering if you can give a sense of like when people would use what here.
Yeah, so basically, with the Gemma 3 family, the way to think about it is if you need the most capable model, local model, then you're just going to want 27B. But if you have for, and if you're curious about quantization, we talked about it a bit in our last lecture, but I'll just go quick over here. If you have an H100, which I doubt many people have in this class, but if you do, you can run a Gemma 3 27B. But with quantize aware, because it cuts the memory consumption by about approximately a quarter, you can run it on a regular like 40, I don't know, 4070, but definitely 4090. So consumer grade GPUs. Uh, However, I don't think everybody's got a 4090 in their laptop. I doubt anybody's got a 4090 in their laptop right now. I don't think
Not
it's a
yet.
laptop grade CPU or GPU. So with that, you can go down in sizes. You can go down to the 12B if you're like Hugo and you've got a totally specced out MacBook that is in the mail. Or
Mhm.
you can go with the 4B if you've got a smaller laptop. And then if you're on a phone, if you've got a high-end phone like a Pixel 9, you can still run the 4B, but most people can run the 1B on their phone. So the 1B is not going to be as capable as the 27B, but it is still a pretty good model to run literally on your phone. I have it on my phone, not the one I have here, but another one. So I have Gemma models on everything. I've got one on my desktop, 27B. I usually run 12B or 4B on my MacBook, and I run a 1B on my phone.
And just
And
out of
so,
interest, what
go
do you
ahead.
use to run LLMs on your phone? I use MLC chat, for example. There are other ones, but what do you use?
Let me check actually real quick. Um, Google has a library called MediaPipe. It's an ML
Hmm.
Edge library. So I tend to use that because being at Google,
Makes
I
sense.
know how it works well, and it's easy for me to learn that particular framework. So maybe at some point, Hugo, we should do an LLM on Edge course. I mean, if people still like these courses, you want that, then
Oh,
we'll spend more time talking about edge devices and small models. Um, so
that would be so interesting. And I think people are cluing onto this now, but the powers that be have, I don't want to get too tinfoil hatty, but the powers that be have, wanted to convince us that bigger is better and large is necessary. And once again, what we're seeing is you have smaller, like well-curated data sets and well-trained models. You can get a lot of things a lot smaller. Everyone remember that Kepler developed his laws of planetary motion, which were the basis for Newton's theory of gravitation on 1900 or 2000 data points that Tycho Brahe, the Danish astronomer, collected. So you don't need web scale data for everything, even to construct laws of planetary motion. So theory is still important. enough waxing lyrical. Let's now jump in, having had a look at Ollama. And in the chat, let us know if you've played around with Ollama, especially people in the course. We've used, a lot of APIs and Gradio and dataset, but we haven't done much local, used local models. So let me know if you've done this type of thing. So I'm going to share. This is clearly too massive. It rendered well on GitHub, but I love it anyway. Just pip install Ollama. It makes running LLMs locally super easy. Okay. You get pre-configured model execution. It's efficient, fast iteration loop. So when we combine Gemma 3 and Ollama, we actually get immediately a fast, flexible foundation for building your first real LLM-powered application running 100% on your own machine. So let's just test everything is working. And if you, I suppose this was in the README instructions, but what you want to do is, if you don't have this model yet, I hope I get this right, Ollama run model name. Yeah, we can see it's doing its little thing here. So this is just, oh, you're messing with me. Okay, so for some reason that didn't work the first time, but now I'm running Gemma 3, and you can see in the command line, I just say, what's up? And it says, not much, just here and ready to chat. Yo, what's up with you? What's on your mind? I mean, they mimic you so well. I'm just going to say bye because I'm outie. That was just by demonstration. But that's how easy it is to run Ollama from the command line. I already had this model installed, but if you don't have it installed, it'll pull it. Note, it will try to download massive models immediately if you do that, so do be careful. So we can do it from the command line, but now we want to build some applications, right? And contrary to popular belief, I personally don't build applications in notebooks, but I do want to show you kind of how this works in the notebook, right? So we do our imports from Ollama, we get our model, we have our singleton prompt where we have our chat response, and we have our roles, user, content, as you may know from, APIs, that type of stuff. And I'm just asking Ollama, what are 3 interesting facts about the ocean? So let's execute that. And if any questions in the Discord come up, I'm not looking at it right now, Raven, so feel free to interrupt at any point. So, okay, here are 3 interesting facts about the ocean that might surprise you. It's interesting. I didn't ask for ones that might surprise me, but, Gemma 3, it wants to surprise. The ocean produces more oxygen than land plants. That is surprising. Phytoplankton, of course. There's a dark zone deeper than Mount Everest is tall. I did know that. The midnight zone, because it's perpetually dark. It actually isn't perpetually dark. I don't think, I think some light comes through like ocean floor crater explosions and then those weird fish with lamps on their heads. And then currents can travel hundreds of years. Beautiful. I suppose that depends on definition of a current, but we've got some good information coming out of. This is amazing that we've got a 4B model that I can run here that, is trained on essentially, the history of human cognition. So now what we're going to do, I've done something in a notebook, I've done something in the terminal, and now we're going to create an app. So Raven, is there anything you want to add before we start building a little app?
I think the easy one is just increase the font size a little bit.
Oh, yeah, absolutely. Great. How does that look? So we've already got Gemma 3, Ollama. Now we're going to introduce another tool. And I actually, for people who've heard me talk before or in the course, I'm very much against tools. I mean, I use tools every day, but I'm against being prescriptive about tools. I think use the ones that are good for you. Start with pure Python, API calls, local models, fast front ends like Gradio, and annotate your data in spreadsheets before moving to, something like Arise Phoenix or whatever it may be. So why Gradio? Why do we do this? We're building an MVP. You get super fast MVP development, can build an interactive AI demo, just a few lines of code about to do it. No front-end experience required. Part of the Hugging Face ecosystem. I mean, that's a huge win anyway, and it's great for rapid prototyping. So I've got an app that I'm going to run that I'll show you where it is, but just have a look at this code. All we have to do is import Gradio, import Ollama, define the model, have the chat with model function, then I define this interface with a chat with model, inputs, outputs, text, and then I launch it, okay? So let's now have a look at this app. It's going to be in the apps directory, Gemma 3 app. Look at this. And I don't actually need 20 lines of code for this. We could do it in less than 10, to be honest, which I think is so darn cool. So let me actually, whoa. Okay. Let me, I had PyEnv issues earlier today, so I'm going to just do this, and I'm going to do, so Python 3, and it's in the apps directory, and it's called the Gemma 3 app.py. Great. Running on local URL. Now, this is cool. I can actually command click on this, and it will open in, but I'm not sharing that screen, am I? So let me now share my browser. And Ravin, can you see the chat with Gemma 3 here?
Yes, I sure can. Although you probably want to make it larger again.
Cool. Okay. So I've now got Ollama running locally. It's running Gemma 3. This is all happening on my local system. So when I can put, I can give this financial details, and I know it will only say local to me, for example, right? And we've just got a Gradio front end in 20 lines of code. So I'm not a huge fan of typing when chatting with LLM, so I'm actually going to use Super Whisper to talk to it. Hey, Gemma 3, what's up? I'm here with my dear friend Ravin Kumar from DeepMind, teaching a workshop on YouTube and chatting on Discord about building AI agents with Gemma 3. Okay, so I just spoke that. I'm just going to correct that misspelling and submit. Awesome. Okay, the response is, that's amazing. That sounds like a really exciting and valuable workshop. Thank you so much, Gemma 3. It's fantastic to be part of it, even in a small way. It's actually a big way, Gemma 3. You're generally interested to hear more about what you're covering in the workshop, and so on. And of course, a lot of engagement farming, like LLMs are fantastic at, because they want to keep the conversation going. OpenAI needs to keep its metrics as well. But it's funny, I haven't done a multi-turn conversation here. So I haven't got any memory in this. So were I to reply to this, we may think that it would have the history, but we haven't done anything like that. So I'm actually going to add one more thing to here. Oh, I just executed it again by accident. But I'm going to add one more thing. We're teaching, at the moment, we're teaching how to build a basic app with Gemma 3 with Ollama. With a Gradio front end, then we're going to log to SQLite, get observability initially through dataset, but encourage people to use spreadsheets. And then we're going to move to building basic agents with function calling with Gemma 3 locally. Ravin is going to be using 12B. I'll be using 4B, the quantized ones. It's exciting. We're excited to see what the different capabilities will be. And then we'll be diving into the model context protocol and setting up an MCP server and client. I am interested, now that you know all of this stuff, is there anything you'd encourage people who are in the workshop to do afterwards? What are some next steps people could do to build on this work? Okay, so it's transcribing. I'm going to submit. Now, this is a bigger chunk, right? So we'll just see. Hopefully it doesn't take too long. Hopefully the demo gods are kind today. While this is processing, Ravin, is there anything in the chat that you'd like to mention?
No, actually, as always, I think it's really cool how you set up this this web app, but it looks like it just came back.
It did, yeah. Wow, this is amazing. I'm literally going to paste this in the Discord as well. And once again, remember, we've talked about memory in the course. Whoa. And Nathan's asked a question about Olama having a field for context or previous conversations. I think you're right, yes, but I haven't used it in this app, right? So just quickly, if after this workshop you want to get involved, experiment with function calls, right? This is huge. Iterate on prompting. Explore different model sizes locally. That's what we're doing, okay? Expand the logging and observability. Prometheus and Grafana. This is actually horrible advice. And I think I wouldn't jump into any of these tools straight away. I do like the idea of expanding the interface. Yeah, and then think about all the types of things you can introduce. I personally wouldn't do a lot of these. I'd try to explore more agentic types of structures. One thing you could do, this is something we're working on in the course at the moment, is have a build a text to SQL agent on some data and build yourself a little data science assistant. Try 3 tools: text to SQL, then a data analysis tool which writes pandas code, then a data visualization tool which uses Matplotlib and Seaborn or something, and see what's up with those. Having said that, I've pasted that all in the chat, and what I'm going to do now is go back to VS Code to wrap up this introductory notebook, because we do want to get to agents, of course. So Ravin, you can see my screen again.
I can.
Fantastic. So what we've just done is we've built a Gradio app where we can interact. So what did we do? We imported Gradio, defined the models, created the function, built the interface, and launched the app. Okay. And we've already done that. Fired it up, started chatting. So we're not going to go through this now, but there are apps in the apps directory which you can do this, and in the previous one. But the point is, if you build software, you want to know what's happening inside it a bit, at least, right? You can YOLO if you want, but it probably won't be that reliable software. So you want to be able to look at your conversations and tool calls and that type of stuff. So you want to log as much as possible, track inputs, outputs, model decisions, making debugging easier. And so once again, in the spirit of MVTs, minimum viable tools, using SQLite locally, you can even like just log local JSON and spin up a custom JSON viewer to inspect if you want. But SQLite's chill because there's no setup hassle, fast and lightweight, portable, easy to share, and just so popular. And so you can go through and do that. And I've included code here, which will do that all for you. And then I won't go through all of that now, but then what you can do is explore your data with tools such as Dataset. And we did that in the previous workshop. We're not going to do that now, but essentially it's an instantaneous database UI, super fast, built-in querying, and then you can export immediately to CSV. And in fact, Dataset's a tool that a lot of I want to say non-technical people, I think probably slightly technical people, but a lot of journalists use it for their data work and those types of things. So definitely want you to check it out. And essentially, when thinking about how we build these systems, once again, we're not going to get too much into iteration, evaluation harnesses, that type of stuff today. But what you want to do is look at your failure modes, see what parts of your system are messing it up the most, right? And what you'll often see is that like your document, your PDF, OCR or computer vision stuff, if you improve that, that will be way better than doing some form of infinite RAG, right? That maybe won't excite your shareholders as much. But yeah, having this stuff in these types of formats, failure mode analysis, sharing with SMEs, manual evaluation, and remember, why are we manually evaluating things? Remember, from machine learning, you want a test set, right? Manually evaluating is just creating a test set, right? That you have some form of quote unquote ground truth that you compare new systems or models against. And this allows you to start some systematic evaluations. And if you stick around in the Discord, we have lots of conversations around those types of things. We're not here to talk about it today, but I'd have to fire myself if I didn't say, if you're trying to build reliable software, these are the types of things you want to do. So just to recap, we've focused on building the first version. We built an MVP system, Gemma 3, Olama, and dude, Ravin, this is so cool. Last time we did it with Gemma 2, and it like switching out the things in this code was the chillest, man. Super nice. And so we built an interactive Gradio UI to test it, talked about logging observability, and all of this is important because these things are more than just models, they're systems, right? And we need to think about debugging, iteration, and improvement. But that's enough out of me. I'm so excited for Raven to take it away. And we're going to start doing tool calls and thinking about the beginnings of the agentic continuum.
Awesome. Thank you, Hugo, for that comprehensive and detailed introduction about how to build apps. So what I want you folks to think about as we do this, and this is coming from a lot of the questions that I'm getting, is that with modern LLM, there's all these different pieces that are plugging together to make the full experience. So for instance, as Hugo showed, what most people interact with is the app and the app UI, and that's, let's call it the presentation layer. And that's quite important, including logging and all those sorts of things. Then you're going to have the model, which is the other thing Hugo talked about. In this case, we're using Gemma. But there's going to be other pieces that are a portion that are part of that. One of them is the inference framework. So that's the thing that's actually taking the model and letting you interact with it. We used Ollama here. I'm going to show off AI Studio in a second. But the inference layer is where you get things like JSON mode, which a couple folks had asked about. And the other thing we're going to show you, which is now coming into the system, is we're going to call it the agentic or the tool calling layer, which is what allows you to plug in external capabilities into the model. And so there's a lot going on. There's 4 pieces that I listed here. And part of what we want to show you in this tutorial is to help separate these concepts so you know where each piece of functionality is coming from, and then so you can build the puzzle pieces yourself. So Nathan actually just led me to the next question. Is there a hosted version of Gemma 27B? So I'm going to show you AI Studio. For folks that don't have a performant laptop or Gemma's not loading for you, and later on when I go to the Gemini portion of MCP in this course, I'll show you what I'm using. I'm going to AI Studio. And AI Studio is an application layer, just like Gradio that Hugo showed you. It goes through a Google inference stack, and then it has models in it. And so the models themselves are here. We have all these Flash 2.5, actually the newest Gemini models. We also have the Gemma models here that you can try, both the Gemma 2 and the Gemma 3 if you choose to use them. Hugo, I think, just posted a really great diagram in the chat, so in the Discord, so go look at that. And so to answer your question, Nathan, yes, there is a hosted version of Gemma 3 in AI Studio. You can use that. I'm going to be using the local version of Gemma 12B on my laptop just because, again, I want to give you the experience where you can run everything locally, but you can choose to use Gemma through AI Studio. You can choose to use it locally. And with Ollama, you're going to get the same model. You'll just get 2 different inference layers. And so to answer the last question about what's called structured decoding or JSON mode, you can get it in AI Studio and you can get it in Ollama. And if you can't figure out how to get them, I'll show you later how to do that. With that though, let's jump into the tool code, tool calling, function calling. They're all sort of the same name, interchangeable names in the Jupyter notebooks. And then we'll go into MCP after that. So that'll be part 2 and part 3 of our tutorial.
Amazing.
So what we're going to be doing is we're going to be grabbing this notebook here, which is basic function calling. I have it running locally here on my browser, but you can follow along again and read along here if you'd like. Let's pull that up.
You're not sharing your screen yet.
Oh, actually, oh man. I went through the whole thing and I didn't share my screen. Classic blunder. Classic blunder. Okay. Let me go through AI Studio again super quick so you can see it. AI Studio over here, you can grab the Gemini 2.5 models and you can see the Gemma models over here. And so you've got all these models available to you. We're going to be using local versions of Gemma for this tutorial. So again, I'm doing everything that you can do locally. And then we're going to switch, when we switch to Gemini, we're going to be using an API key from AI Studio to the Gemini function calling. All right. So with that,
I just also, I know I say this all the time. I love AI Studio, man. You've all done such an amazing job. I also, one thing I love about it, there are many things, but the ability to experiment in the UI using knobs and faders so to speak, and buttons, and then to like click get code and copy and paste that into my own VS Code or whatever I'm using at the time. That's boss move, man.
I'm glad, and I did not pay Hugo to say that, so I'm just actually
Definitely
getting
not.
feedback.
Although if
Uh,
you're open to it, no, I'm kidding, man.
I gotta send him I'll send him the payment afterwards to Australia. Okay, let's jump into creating basic agents. We're gonna go through about like let's say 5 minutes of lecture, and then we'll go into code. Um, so one challenging thing I'll just say at the beginning about agents is you suddenly have a lot of things happening at once. So in a basic chat app, you have the text going in, you have a model response. There's really only this line up here. Um, there's not much else, which makes it easy to reason about. Once you start doing tool call, you start having a lot of different things plugged in. You have results, you have tool calls and response, you have read and writes potentially to memory. Um, and with all these different layers and things happening, you really have to understand which part of the stack you're in or which part of the flow you're in when you're debugging. And the other hard thing is typically users don't see all this stuff at the bottom. They only see a couple things at the top. So if you use tool calling bots, once you dive under the hood, there's a lot more complexity than you're exposed to. We're gonna talk about all that here, but I encourage you to ask a lot of questions all the way through if you're ever confused, because again, we're doing this tutorial for you, and we want to make sure that you have all the knowledge to be able to create agents yourself, or at least understand what's going on.
Exactly. And I'll just add that, I've said agents, they're super exciting. It is a marketing trend in some ways, but why are we so excited about them? The reason is that LLMs are amazing, but they seem somewhat quaint now. And don't get me wrong, they are incredible, but chat conversations don't scale that well, right? In terms of the time it takes. So if we can automate things, that seems cooler. So then thinking about if these things we can chat with and contain somehow the sum of human cognition or can mimic it, let's see if they can do things as well. And we're at that stage in history where we've built these things and we're seeing if they can do things. And early signs are incredible. But I think one thing to make clear is if you're building software with agentic type things, I'd be careful because these type of systems are great if you have a knowledgeable human in the loop. So when I use an AI assistant like Cursor with, Gemini 2.5 in max agent mode, that's super cool. But it's because I know the failure modes and I know what I want as well. So it's still highly experimental is my point there. Would you agree with that characterization, Ravin?
Yeah, I think we're like Hugo said, we were in a world of chat, let's say 2003, 2004, and we're now learning collectively together how these models can be used to actually go do things on their own, which is in some cases really cool, or in I think all cases really cool. You have a personal robot that's programmable and can take actions for you, but we're again all learning together how to best do that, both at a programmatic side, like what works best and what helps the robot do what it's doing, but also where is that most useful for folks like yourself or others? What kind of situations would these automated systems help them out the most? So let's go through and let's talk about what it takes to build one of these automated systems. There's going to be a number of new terminologies. So the first one, let's say the highest level concept is function calling or tool calling. Um, you can think about this as the ability for the agent to go do things. So for just a moment, I'll talk about what an agent is because we have it here in bold. An agent is essentially an LLM in a while loop, which can call tools. But I want you to take the agent vocabulary out of your head just for the next 30 minutes. And we're just going to focus on tool calls and function calls. And you can think of these two words as equivalent. It just depends on who you're talking to. And even in this notebook, we mix them. But yeah, they're exactly the same thing. Now, for an LLM to be able to call a tool or call a function, there's three parts, which we have in this notebook. And I'm going to show you each of those portions individually. There's the function definition. It tells the agent what, sorry, I should stop using the word agent. I should also use LLM for a second. It tells the LLM what tools it has access to. So there are a lot of tools out there now. Actually, at this point, probably tens of thousands of tools that people have exposed in various ways. but your LLM won't have access to all of them automatically. So function definitions tell the LLM which tools it has available. The LLM then, as part of its magic, can decide if it's going to call a tool. So in the conversation history or in the course of a conversation with you or some input, it can say, you know what, rather than say something to the user, the best thing to do is actually go call this tool. We're going to call that a function call or a tool call. And then the tool will respond. We're going to have a very basic tool in this case. It's going to be a super simple Python function, but it could be anything. It could be an API call. It could be a database call. It literally can be anything that you can program. That thing is going to provide a response. So if it's, let's say, a SQL query, that SQL query could provide, a tabular data set as if anyone who's been in data science for the last 10 years has seen. Or it could be the weather, as we're going to see in a second. Or it could be all of the restaurants in an area. The LLM, though, is going to have to incorporate that, like, let's JSON or tabular data into its natural language response. Or I should say, it can choose to incorporate that into its response if it wants to. But it's really these three pillars or these three ingredients that make up the entirety of a function call. So Hugo has provided one diagram here, and then I took this one from the Google Docs for Gemini. So you could replace Gemini with Gemma, and it's exactly the same thing. But you have this entire sort of loop where you could go back to an answer, or you could go through this function call sort of maze here. What we're going to be doing is we're going to be going through every single piece and wiring up every single one of these. So we're going to see a lot of if and else and while loops that are going to build out this entire framework from scratch. Now, as Hugo mentioned earlier in this live stream, a lot of this is now built in to various places. So if you're using an external framework like LangChain, which the Gemma 4B had advised, this wiring, a lot of it's already built in. If you're going to be using an MCP client, which is now, another thing, a lot of this wiring is built in. But again, we're going to be building each one of these wires from scratch in this notebook so you can see everything that's going on.
Ravin, we have a couple of questions which I think this will come out in the wash, and they're very important questions, but I think it's probably nice to just flag them. Pascal has asked, is it in the prompt where you decide the order of execution of tools for the agent? And I say not necessarily. And as we'll see, what actually happens is, and this isn't in all systems, but a lot of the time, in our example, we give it a get weather tool, okay, that allows it to get the weather. And then when you ask, it only has one tool, then you ask it, what is the weather? The LLM, its output will recognize, quote unquote, that tool will be useful. So it will, quote unquote, suggest that tool. Then you need to automate that. We write the code to automate that. But I suppose the point is that as a builder, we don't really decide what tools are used when all the time, do we, Revin?
No, well, I should word it this way. I think people take this binary approach of whether, users do everything or agents do everything. But really, if you're the builder of these systems, you actually get to make the decision of how you instruct these models and how autonomous you want them to be or how manual you want them to be. So this is part of what Hugo and I were talking about earlier. As we're all learning how these things work, I'll say this for me, even on the Mariner project, which is a agentic web browsing agent. We're doing a lot of experiments internally to decide how automated this tool should be, or how automated Mariner should be, and how manual Mariner should be. There's cases where you'd want both, and dialing that needle is an important thing with the product. And also, users can decide how automated and how manual they want things to be. There's some controls we've exposed in that product, for instance, where you get the choice of whether you want it to be totally automated, or I shouldn't say totally automated, but more automated or less automated. It's one of these things we're learning as we go.
I love it.
I used to be a mechanical engineer, so I have a lot of car examples, but you can think of it like cruise control on a car. When you had an early car, everything was manual. You had to pull the gears yourself or change gears yourself. You had to start the car manually yourself with a crank in the front, like they were full manual. Over time, we've learned people really don't want to start a car manually through a hand crank. That's actually pretty dangerous. So that process is largely automated. Most people don't want to shift gears, so that process is largely automated. But one that's half and half is a cruise control. a lot of times people want to start driving the car themselves and they'll control the acceleration. But once you're on a highway and it's really just big stretches of road, like Hugo has in Australia or I have in California, and not Midtown Manhattan, we just want to set a cruise control and let the car decide how fast it wants to go. Um, we're reaching the same thing with LLMs. There's all these controls are getting built in for you to be able to choose how automated or not you want it to be.
And I've also just pasted a link to, and we can wax lyrical about all the different definitions and this type of stuff, but it's a Hugging Face blog post where they say AI agents are programs where LLM outputs control the workflow. And that's when we talk about LLMs making decisions or being autonomous, what we're really saying is that the output dictates what workflow happens then. And I'm concerned about certain forms of anthropomorphization. So that's why I like the idea, as opposed to making a decision or something like that. It's the output that dictates the workflow.
Cool. So let's go through the bulk of this tutorial. So people should leave questions in chat. But I'm gonna queue them up or buffer them up till the very end because I think you're gonna see how this whole thing works, and then it'll be much more concrete to answer all these questions that you have, rather than us Hugo and I just waving our hands. Well, we know what's going on because Hugo and I have been working with this code for a bit. But I suppose some of you folks don't understand just yet, but only for the next 15 minutes.
Please do say anything in the chat. And in all honesty, I'm in my office right now by myself. Like I miss like teaching and chilling in person and building together. So let's just shout at us and we'll figure it out.
Cool. Okay. So let's define our first tool. So if this looks like a basic Python function, that's exactly what it is. We have this function that gets the weather if you give the city to a oh, let's see revert just
Do you want to zoom in just a bit as well?
Yes. Yes, of course. Let us show you the first tool. So we have this function that gets the weather. This is just a basic Python function. There's no AI. There's actually even no imports required for this function, really. All this thing does is if it's given a city, it's going to return the weather. And so Austin and Sydney are going to be sunny, and whatever else is going to be cloudy. Now, in the real world, of course, this function would call an API, and we have an example of that earlier, lower in the notebook. But for now, we want to, again, show you all the magic, and or actually, we don't want anything to be magic. We want you to see it all. So we have this tool which is called getWeather, or a function which is called getWeather. So keep that in mind.
And just
Next
quickly,
we have
it looks like do you need to lowercase Austin in order to get the actual?
yes, I think I just fixed that.
Yeah. Well, no, because it still says cloudy when you.
All right.
Yeah.
Quick debugging. All right. So
Great.
actually it should still work. Let's see. All right, perfect.
Oh yeah, great.
That's my code. All right, so that's our tool. Hugo covered the basic chat functionalities. So, oh man, of course we always have issues. Oh,
Yeah, because you're using 12B and I'm using 14.
I'm using 12B. Oh my gosh. Everything always live demo gods, huh?
No, but this is the best, man. The demo gods are vengeful and spiteful, but there are lessons from the gods as well.
Oh
And
my gosh.
I think everyone seeing this is helpful as well.
I know. Man, with blood memories, it literally was just working right before I started this class. So this is
Of course it was.
this is always how it goes. Man, what the heck? Okay, give me a second. I need to you're gonna watch me debug live real quick.
Amazing. Talk us through it.
Olama LS. Let's see what I got. I've got 12B. I guess I don't have the QAT version. So okay. My mistake. I did not pull the QAT version. So I don't have the QAT models, but my computer should be good enough that it can just run it can just run 4B. Okay, back on track. So real quick aside, what I did there, I forgot which models I had locally. I had some and then I deleted some and I brought them back. So I don't have the QAT versions, but luckily I have a laptop that can run 4B in full precision, and you can see that it's 3.3 gigs here, and I pulled it 5 weeks ago. So we're gonna use that model. And let's go ahead and continue. So I have Gemma 4B running. I guess we're going to go with that because I'm not going to pull 12B at the moment. And I have just a basic chat response. So I give it a prompt, say hello to the class. It goes ahead and says hello to the class. Exactly what Hugo showed earlier, so we won't dwell on that. Here's the first new concept I'm going to introduce to you. It's called a system prompt. So if you haven't heard of this terminology, what's typically happening in most LLMs, especially though, I will say with more complicated products like agents, you provide your user prompt, which is part of the input, but there also is usually this thing called injected, called a system prompt, and that's happening at the application layer. That could be the designer of the model. So that could be, or sorry, the designer of the application. So in this case, it could be Hugo as the designer of the Gradio app, or sometimes it is even the model vendor themselves, like in Google. And so I won't say the French word on this particular call, but Hamal has this great blog post called, FU Show Me the System Prompt, where he talks a lot about system prompts. What we're going to be doing here is we're going to be augmenting our user prompt with a system prompt. And so what that looks like in the simplest example is you take your system prompt and your user prompt and you just concatenate them together. And so I have this function called augmented model call. And what I have now is I have a system prompt and it says talk like a pirate. And so I'm going to give that to my augmented model call. I have my user prompt, which is the same thing that we have here, but let me copy it down here so you can see all of it together. So I have a user prompt, I have a system prompt. I'm going to go ahead and run this. And now you see what's happening here. Users will just say this, but because the system prompt is getting added at the top, Gemma now responds with this very piratey response. Very different than just the standard say hello to the class. All right. So far, nothing tool calling related, nothing agent related, nothing function related. We're just going through a basic chat workflow. Here's where we're going to get to the first part of function calls. So we're going to tell the model that it has a function available to it. So we're going to say, you have the following function available. It's called getWeather, and it gives a city. Given a city, it returns the weather for that city. So the model knows that there's going to be this function that it has available to it. If you call this function, we want you to give a response that looks like this. It's going to be a particular list, and it's got a little JSON object in it, or a little dictionary, and it's going to have city as the key, and it's going to have the city that the user asked for as the string value. So going back to terminology, this is going to be the function declaration. And if the model decides to provide a function response, the if, it's going to give it to you in this value. So let's go ahead, and I'm going to run my user prompt here. But I'm going to call the augmented model call, which is injecting this system prompt. So I'm going to run it, and let's see if the demo gods are with me today. Oh, okay. So I have not run the system prompt, so use my pirate one. You can see that okay, that was an accident, but again, a good live demo. When I have the wrong system prompt, it gives me a weather-related thing in pirate language. But let's give it the right system prompt. And you see that the response has changed quite drastically, actually. The system prompt is now telling the model that if you get a weather query, that it should respond with the JSON. And that's what we see here. Let's ask about Austin similarly. And you can see again, the model figured out that we're asking about Austin. Let's ask one more about London. And now we're getting London as a response. And so I want to pause here because this is a key concept. The model knows it has access to a function, but a model by itself cannot call that function. The best it can do at the moment, so just at the moment, is it can say that, hey, application framework, I want you to call a function for me. It's not actually calling the function itself. So let me scroll back up to the diagram just to be really clear here. It has a prompt, and in this case, it decided that it wants a function name and an argument, and it's put that here. Let's ignore function name for a second. We'll come back to that in a second, but we definitely have the argument at the moment, and it's going back, and we've currently gone through this particular loop here. Let me go through one example where it goes through this loop here. So let's go ahead And let me write something else down. Let's copy this and just say, go back and let's just say hello to the class. Maybe I'll just say hi. Let's keep it simple. And hey, it just says hi. Say hello, say hi to Hugo. Hey, hello, Hugo.
Hey, what's
And so you
up,
see,
system?
it's not asking about the weather. Yeah. It's just asking how Hugo is doing, or just saying hi to Hugo. And so what we've covered so far is this thing. The model decided that it wants to respond with a completion and give an answer. It does not want to respond with a function call in this case, with an argument.
And this is initially a weird pattern to get used to, really, to be honest. But what happens is an LLM recognizes that, you're asking about the weather, for example, and then it's like, oh, I have a tool, there's a tool for that, and it outputs the tool or the response that the tool would like, and then we encode, write out that tool usage, which we'll get to in a second, and then we can build that into our system. Take it to a slightly bigger example, the one I mentioned earlier. Let's say you have an AI, a data science agent, which can query a database with SQL. It can do data analysis and it can create a visualization. It has three tools there. This one only has one tool. The one I'm talking about has three tools, right? And so you give a query, and the LLM output will suggest or control or dictate which tool it thinks you should use. But it may not always get it right as well.
So I see a couple of good questions that I want to pause and answer right here. One is Mike asked, is the system prompt a recommended way to specify tools for Gemma 3? Is there a structured API? So there's two questions here at the same time. One, is there a recommended system prompt? Yes, we have a Gemma 3 function calling docs, and let's see how good I can Google and just show you what they are right now. Go ahead and keep with me in the tutorial right now and don't read this because it's going to be hard for you to follow both at the same time. Sorry, let me close that. It's going to be hard for you to follow both at the same time. Just go ahead and just watch the YouTube video for now. But these are the recommended docs that we'll come back to later. The second thing is there a structured API call? So again, this is a common misconception, but I want to reiterate this. There are models and then there's inference frameworks. Every model is just a set of floats on disk. There's no API or anything for even Gemini or the Gemini models or GPT 4.0 or anything like that, because they're just literally a bunch of values on disk. What provides the API for everything, including Gemma, is your inference framework. So if you use like a Gemini, you're going to use Google's inference framework because we don't publish Gemini weights externally. You have to use our API, and it's the same for, let's say, Claude or OpenAI. But for models like Gemma, since they're open weights, you can deploy them in whatever inference framework you want to deploy them on. If you want to use Google's, go ahead, use AI Studio, and we wrap it up in the AI Studio and Google first party inference framework, including with our TPUs. But you can use Ollama to run it locally, which is what I'm doing here. You can use Hugging Face transformers. You can use VLLM. Like you, as a user or as a Gemma user, get to decide what inference framework you want to use. So in this case, there isn't Ollama provides an API for all of its models that are running in Ollama, which is one reason I really like using Ollama. Okay, Mr. Me asks, how deterministic is tool calling? Everything in LLM land, nothing is actually deterministic. That's the magic and the fun of LLMs. They get all their interesting and nice behavior because they're not deterministic, which is a blessing and a curse. It's the nature of the game with LLMs. So no chat response from LLM is deterministic, except for some really constrained settings, which we could talk about at the end. And likewise, no tool calling is deterministic either. I see some other questions, but we'll come back to those at the end. Let's go through and talk about the next couple sets of the tool calling framework, and then we'll go back. Okay. So if you remember from our diagram, the next thing we need to do is we need to parse the response and execute the function. So there's two things happening here: parse response and execute function. So if this looks like a bunch of Python code and nothing like an LLM, that is exactly what's happening. There's no LLM magic here at all. This is just plain old Python. what we want to do is we want to parse out the regex pattern from our model response. So our model response could be like this. And I wrote the regex that will take this JSON and it'll pull this out and give you back a nice Python dictionary here. Again, all that's happening is we're taking a string and we're parsing out the city Austin. But the cool thing now is that we can grab this out and we can call our getWeather function quite easily. Like you can just go in and grab the city and we are good to go. And so what we're going to do is we're going to wire this all up together in one big function. This one big function. And I should be function really clear. One big Python function. So not a model function, not an LLM function, but we'll call it our chat framework.
It's functions all the way down.
It literally functions all the way down. Some of them are yours that the LLM doesn't have access to. Some of them are the LLMs. But here we have the system prompt. I just slammed it in here. It's just a string. We're going to get a model response. It's an augmented model response. We're going to see if we get a function called JSON out. And if we don't have a function called JSON, we just get none from our model, from our system. So if I make this really explicit for you, return none. So, in Python, if you don't specify the return, you get none. I've just made this really, really clear. So I'll just show you that. So there's, again, no magic. We'll just do a basic Python tutorial. The model response is hi, Hugo, like we had earlier. You're gonna get none. And to make this super explicit for you, I'm gonna print this so you can see it. We're gonna get none back. So if we get none back, we get no function called JSON. We're just gonna give the model response back. What this is our first kind of loop here. We just give back the completion. If we get a function called JSON though, we are going to put it into this into a new prompt. The weather in the city is whatever. Tell me the weather nicely. And it is going to call the model again. We're going to give this prompt to the model. And then we're going to get the model response. So let's go through a chat interaction. Can we say hi to the class? Awesome. Can we say hi to Hugo? Let's do this again. Yes. Hi, Hugo. So you can see I have a basic chat app. But if I say, what is the weather in London? And this becomes a little bit deterministic. Oh, again, the demo gods don't love me today. Let's try Austin. All right. So now you're going to see some live debugging. People were asking me before whether this is deterministic or not. You can see right now that we are running into a little bit of regex parsing issues at the moment. So let's see if I can figure it out. Otherwise, I will go back to the reverted version of the tutorial. How is the weather in London? So let's go ahead and debug this response, and you can see this live with me. So import PDB, set trace, and you're getting a feel for some live coding. I'm gonna comment this out. All right, let's try this one more time. Let's go and see what is going on. Okay, so we're in our function, and okay, it's because we do get the city back, city London, but of course, as everything works, as everything regex related goes, you always have to debug very, very boring things. Okay, so the reason is we don't actually need this second zero out here, so let me pull that out for a moment. I think there is something a little bit different about this model call, and we'll give it 1 second. Oh my gosh, okay. Let's go ahead and get rid of our debugger. And guys, this is how you know Hugo and I are actually doing this stuff. We're trying this out. All right,
Constantly.
perfect. I got it working because it was just the JSON function. Everything regex related is always such a pain. All right, how's the weather in London? As you remember, if it's not Austin or Sydney, it is cloudy. So it is a lovely cloudy day in London. All right, perfect. How about Austin? Absolutely lovely again. We're enjoying the sunshine. Let's actually make a slight change here. Let me change this prompt to say, tell me the weather as if you were a pirate. Let's give it. I'm going to update my response thing here, and let's run this again. All right, and now this is a pirate response. So you can see what's happening here. Um, we have defined a full agentic loop. Really, it's a combination of the system prompt. It's a combination of parsing the model response, if it's a tool call or not. And if it is a tool call, then we give it back to the model with the new information, which is that city weather, and then we get our response from the model again in this nice format. We could change this to an API, and in fact, Hugo has done this before the class. Last week, he made this a real API call. But this is everything you would need to have a Gemma model call the weather and know what the weather is every day. So the last point I'll make here before I look at questions is that there is no way for any LLM, whether it's Gemma or whatnot, to know the weather in every city. Because when LLMs are trained, we don't know what the weather is tomorrow. Very few people, in fact, nobody knows exactly what the weather is tomorrow. So if you look at a lot of docs, you'll see get weather as the sort of hello world of function calling, because it's one of these things that like people expect an LLM to do to know the weather, but a model by itself will never know the weather. So modern implementations, like if you go to Gemini app, it will actually call an API behind the scenes, get the weather, and then incorporate that weather into the chat response so users can get that information, even though that information doesn't exist in the LLM weights itself.
Yeah, and one needs to be careful as to when an LLM is drawing on its weights and hallucinating, and when it's actually, checking out stuff on the internet or wherever. Actually, yeah, ChatGPT is a great example. I'll be like, "What's up?" I'll ask it a question, and it'll be like, "Oh, this is the answer." And I'll be like, "No, you just hallucinated that. Can you check the internet?" It's like, "Oh, yeah, I will do that." Sometimes it'll be like, "Oh, I can't check the internet," and you have to tell it that it can, and then it realizes it. Similarly, when doing AI assisted coding with Gemini 2.5, for example, in cursor agent mode, I'll be like, "Hey, can you look at this notebook?" And it'll say, "Oh, I did. This, that, and the other," and it'll just make up a bunch of stuff. And it will be clear that it hasn't used the notebook inspect tool that it has access to. So then you need to explicitly tell it to as a user as well. There are a couple of questions in the chat that I wanted to get to. One I actually think is really interesting. So, I mean, they're all very interesting, but no. So, to be clear, all your questions are incredibly interesting, but this one is interesting because I have no idea, and Ravin might, although he may not be able to give away secret source. Nowya has asked, is there any difference between concatenating the system prompt to the user prompt or passing the system prompt in its own argument? Now, the answer is always yes, because the LLMs do something weird with system prompts. I've never seen any documentation on what's actually happening, but I honestly don't know like what the LLM does. It may say, "Hey, this is a system prompt that we want you to X, Y, and Z, blah 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 blah." It may do that as opposed to if you just include it. But I've seen no documentation into it. So, do you have any insight that you're able to share without giving away the Coca-Cola recipe or Gmail spam filter, Ravin, about what the hell happens with system prompts when we send them to Gemma 3?
Yeah, so it depends a lot on how the usually the application builder decides well what they want to do. But it could be a combination of things. I will say the good place to see this, well, with Gemma models, you just put the two of them together, and it's fine. If you go look at the other open model documentations like Quen or Llama, they have different implementations. And so the last thing is it depends on how the model is trained. This will come up with some of the other questions. How the model is trained is what really defines the behavior of the model. So some model providers may train the model to respond to system prompts some way. I don't know what the other model vendors do because I don't work for them. But in Google, we're constantly experimenting with different ways to get the best experience for users. So even over time, um, there's been different research and different even experiments internally as to what works best for folks. We'll go to the function calling documentation for Gemma at the end, and I'll show you. But with the Gemma models, we designed them to be quite flexible for different use cases. So we're less opinionated about what the prompt should be. We try and make the Gemma models fit what you need them to do the best because as model builders, we don't know what you're going to do with the models or how people are going to use them. So our intent was to make them really good at what's called instruction following.
Yeah, but I suppose my point also was like you give LLMs tokens. So it's giving them like the user message and the system prompt. And how is it doing that? Or
So
how?
it depends on the model train. You said at the
Yeah.
lowest level, you're giving the models tokens. How the model responds depends on how it's been trained to respond to those tokens. So system prompts are sort of like a programming convention sometimes. Like Python can read functions or it can read classes. But to the code, it doesn't matter which one you use. You could express things both ways. System instructions, in some sense, are a convention that makes it easier for us to reason about what should go where, and the way it responds depends on the model training. So it's a little bit of both.
Yeah, makes sense. Nathan has a great question as always, and he's doubled down with an edit. Do you suggest fine-tuning to improve a model's ability to call custom tools?
Yes.
And
So
then he
to
has a
go to
question
that
about how to evaluate it.
Go ahead. Yeah. So to the previous point you made, fine tuning or training in general is how a model learns how to respond to things. If you know you have a set of functions, or you know you want your model to be, let's say, more likely to function call than usual, then fine tuning is the choice, right? That's how you can train your model to call functions more than usual. I actually have a good example of this for Gemma 2 2B, where we teach it how to output a JSON for a bakery example. Let me actually see if I can find it on YouTube at the moment.
And
Because in that case, you'll see all of the all of it. Gemma Bakery. Wait, let's see if I can pull this out for you. So this is a entire tutorial I wrote with Google, which shows you how we can turn a regular Gemma model with fine tuning into one that always calls functions every single time and never produces or should never produce a chat response.
incredible.
Um,
So please,
so
can you
that's
share that in the Discord?
of
Um,
course.
and while you're doing that, I will say, and I presume with the fine-tuning stuff, you have more insight into how to think about evaluating this. But I do think, and this is something we'll go through in the course this week, actually, with function calling evals, there's something very nice in that it's binary or multi-class classification a lot of the time. Like what tool is a tool called based on input, right? And in terms of developing like a, a gold standard test data set, that's machine learning, right? That's actually like you've got input and a label, which is you want deterministic. So you can have that as part of your eval harness. You don't even necessarily need an LM as a judge or anything like that. You're going to literally see whether your new system, if you need to evaluate it, will do the tool calls that you have in your gold standard data set. That's one way to think about it. Do you have other ways, Ravin?
I think you brought it up well, and this is actually it could be a whole lecture in and of itself. It's just in the if I go to the highest level, it's kind of just like any eval. You know what the input is, you know what you want the response to be, and you check it. But as you're correctly cluing in, there's a lot more things to check and a lot more. Um, there's a lot more. I don't want to say that could go wrong, but as you can see, actually, there is a lot more that could go wrong in the sense that now you're evaluating your model and your inference framework kind of at the same time. This was a really good example here. We sort of ran a mini eval by accident, in which case my model was doing all the right things, but I was getting screwed up at my application level. So there's just lots of different pieces with function calling to go through, to be quite frank with you, and even from my own experience building applications that use function calling. All right, and there was one more question, which actually is the perfect question for the tutorial. It's from Mike Powers. He said, so the response doesn't specify which function the JSON formatted parameters apply to. Is it going to provide a list in order of the parameters for each specified tool? So this is a really key point, and you caught it even before I explained it later. With this particular setup, we have hard coupled the get weather function with this LLM. Like it would actually be pretty challenging and also pretty annoying, as we'll talk about in a second from a programming standpoint, to allow this model to call other functions. So let's say we had another function that was buy me a cupcake or something like that. It's not easy to just plug that in. You're going to have to do a lot of work to plug that into the system prompt. You're going to have to write more parsing code. There's a lot of different pieces you need to do to make that work. You're also going to have to tell the model which function to call, sorry, you have to tell the framework which function to call, and the model is going to have to know. And so it's not super straightforward to plug other stuff in. It's actually quite a pain. And so that's what MCP is going to allow us to do. Actually, then this is part of the excitement about MCP. Um, Let me introduce it real quick. Let me do the conclusion for lecture 2, and then we'll go back to MCP. But basically, you saw this error where people were hard coupling the tools with the models. A really good example of that is the Gemini app. If you go to gemini.google.com, that is not just the Gemini model. Unfortunately, sometimes their naming is not so good at Google, but that is actually the Gemini app, which includes all these extra functions like map and search and all these other things. But those are really coupled together. We have a Gemini model running, and it sometimes decides to call the Maps API or I think now it can actually call it the Gmail API. I have to double check. And call various other Google tools. Um, but again, we had to do a lot of work to couple them together. In this new phase, users want to bring their own tools. And MCP is that framework which allows users to plug in whatever tool they want to the LLM as it's running in an inference framework. And so we'll get to that client inference framework and that model inference framework in a second, or that server inference framework in a second. But let me go through the recap, check if we have questions, and then we'll go back to MCP. So to recap what we're doing, function calls aren't magic. They rely heavily on the model to reason when to decide to call a function or not. And modern models are getting really good at that. So I will point out Gemma 3 is actually particularly good at that. I don't think Gemma 1, we would have been able to do this tutorial with Gemma 1 or Gemma 2, just to be quite frank with you. Those models are not as reasoning capable as Gemma 3. So got pretty lucky that Gemma 3 came out. But even within Gemma 3, through our own evals, and even through public external evals, we know that 27B is actually the best function calling model. It understands what to do the best. 12B and 4B are adequate. They get the job done. And actually, 1B is not very good. I'll point out, if you're going to do function calling, you don't want to use the Gemma 3 1B model at the moment.
But to Nathan's question earlier, could you fine tune it to get some?
You could fine tune it, yes. So a lot of people actually have done this, and they've done it even with Gemma 2. Gemma 2 is not a very good tool calling model, but a couple of external developers decided to fine tune it to make it a better function calling model, and they released it on Hugging Face, and now there's a version of Gemma 2 that is better at a function calling.
So I'm actually really excited. As you know, Raven, I'm getting a new laptop. I'm getting a beefy laptop, and I've got a lot of travel coming up. So I'm actually very excited to see what I can build locally with as small stuff as possible. Super exciting time.
It is exciting. I mean, I'm glad that my laptop runs the Gemma versions as well, because my previous laptop could not. The next thing is to note is the model doesn't actually call the functions itself. I think this is another common mistake. People think about the LLM as being the smartest thing, and they somehow get all the stuff magically. The LLM doesn't actually call the function. The LLM just produces an output, and the LLM framework goes, hey, through just plain old programming logic, not LLM magic, goes, hey, this thing looks like a function call, or from some strict, sorry, I shouldn't say this thing looks like a function call. Through some very strict regexing or programmatic definitions, it says this is a function call, and it then calls the function in just plain old Python or Node or whatever code you want, Go code, whatever you want. And it just grabs that function return value through the standard the standard programming stuff that we've been using for 30 plus years at this point. But that framework then re-injects that into the LLM, which then provides this natural language response. And as Hugo showed earlier in the class, as a user, you don't see all that happening. All that sort of plumbing is hidden away from you. So it looks like the LLM is doing all of this magic, but it's a really tight orchestration between the model making some smart choices, the program or the framework actually calling the functions and grabbing those values, and then putting those back in the LLM for you to see the final response. And so we provided some actual functions like real APIs. Hugo did some experiments where he grabbed the weather from a real API where it's coming in live, not just my faked out Python function from earlier.
Oh, and also just on that, I have linked to something else, which I'll link to again. It's a repo where I have some code, like all of this stuff is templatey that I want to share with people, to be honest, so people don't have to write all this stuff themselves. I'm going to share it again, but it shows you how to do this with OpenAI as well. And maybe if we want to look at it briefly at some point, we can. But it just shows how to do it with a vendor API, and you see a few differences there.
Very cool. So How much time we got? 30 minutes. So we'll keep cranking so we can get to the MC portion, and then we'll see how
Awesome.
much we have for questions. Um, if you want to try this out, go ahead and plug this into the LLM yourself. Um, I provided the London latitude and the London longitude for you, so you can provide a key lookup. But go ahead and make this real and grab it to the API. The last thing I want to do before we get to MCP is talk about tool calling versus agent. There's this really funny, re-depiction of a meme that just came from Hugging Face just a couple days ago. It's just in time for this tutorials. Uh, it's just literally an agent with a loop or an LLM with a loop, and that's all it's going to be. You're going to see that in a second. It's a for loop or a while loop, and you essentially have an agent. So I have the basic definition here at the bottom. The model suggests an action, but it's our code that decides what happens. That is an agent. So for the folks that wanted to see what an agent was, you could drop off this YouTube live stream now. I of course don't hope you do. I hope you stay for the MCP portion, but that's all it takes to build a very basic agent. All
Well,
right.
funnily, they say it's the year of agents, but MCP is definitely quote unquote sexier at the moment.
Hey, so yes, actually, what's funny is when Hugo and I were talking about this YouTube live stream about even just 5 weeks ago, 6 weeks ago. We were just going to do this on tool calling and agents, but the MCP thing got so popular in that time that we figured we have to talk about it and we want to show it to you. So we built that portion of it kind of halfway in our development process. So let me flip over to that now. You folks can see it. There are a couple questions that I'll get to in the end, but let me at least walk you through what the MCP code looks like.
And before
Um,
we could you once again just motivate MCP briefly why people would want to use it, and then what's up with like A2A coming out of Google at the moment? Like what are the different things in the landscape?
Yes. So right now, oftentimes when you're working with tools and LLMs, previously they were pretty hard coupled together. Like your product would be pretty hard coupled to the tools, and just as we had here. So really, the designer of the inference, probably not the inference framework, but the designer of the product would have an LLM. It would have some tools, and let's say it would glue them together pretty strongly, just as we see right here. But as we move forward, you as a user might decide actually, hey, I want to plug in some tools. I want to add in the a bot for this, or I want to add in a tool for this. And MCP is, as Anthropic rightfully calls it, is the USB-C connector of tools. In that you as a user don't have to think about what you're plugging in. It's just a standard way for you to be able to plug things in. Now, I will say this, we're going to talk about this in a second. The specification is changing quite rapidly. Like this is honestly at the very cutting edge of LLMs and the LLM ecosystem. So we'll talk through the high level of how that works. But no, this is a work in progress from everybody. Not actually not even just Anthropic, from Microsoft, from Google, from OpenAI. Um, the companies are now aligning on the spec, but the specifics are still being defined in many ways. So if you're watching this tutorial far in the future, I want to point out at this moment in time, we're going to go through the concepts, but I'm guessing within 3 or 4 months from now, things will have shifted. It's just, the newest frontier again of inference in LLM frameworks. All right. So let me talk about MCP in just a second. Let me actually pull up the MCP docs. And there were some nice pictures.
And just zoom in a
So
bit if you can.
Oh, yes. I'm not going to go through all the docs here. The docs are super extensive, but I want you to know that if you want to dive into the guts of MCP, you should read through these docs. You can use an AI to read it. You can read through it as a human manually, your choice. But essentially, MCP have these couple of concepts. You're going to have a server and you're going to have a client. These are the two highest level concepts of the MCP sort of paradigm. And then within the server, you define a set of the prompts, tools, or resources. There's a whole thing here about each one of those. I'm going to fairly quickly show you a working local version of MCP where everything is running locally. And then I'm going to show you a version where Gemini is calling the same MCP server. The reason I want to show this to you is, again, so you can go to a self-contained tutorial that doesn't have to call any APIs. But you should read both to get if you really want to dive in, you're going to need to read both. All right. So everything I have here is going to be in the same apps directory that Hugo was showing you earlier. You're going to have two servers, a weather server and a test server, which we'll talk through in a second. And then you're going to have a Gemma client and a Gemini client. We're going to focus on the Gemma client and the weather server for this tutorial. All right. So if you remember, in our notebook tutorial, we wanted to call the weather, but we defined that function in the notebook itself. All we've done is we've taken that weather tool and we've put it right here. There's some MCP magic where you put in a decorator and you declare this as a tool for the interface, but it's literally the same logic right here, same weather tool. We've also taken our weather prompt, our system prompt, and we've put it right here. Again, there's there's this decorator in Python, which is exposing it as an MCP prompt in the server, but it's the same weather function as before. Actually, and I needed to delete this one, which is, I think, a mistake. And then we have the weather response prompt right here. So let me go ahead and comment this out just so we don't confuse ourselves. Apologies on that, folks. We have our MCP prompt here. So this is just the same prompt as we had before. It's just the prompt we want when we get the weather back. We're using some libraries here, FastMCP. It, as the name implies, makes it easy to run MCP servers. I probably should call this weather server, which I thought it was called. So give me a second. And so we have this weather server. So I should put this down right here like that. And now we have our MCP server. If I want to use this server, I have to run it and actually run it as a server. And I don't know where my terminal is. Let me find that. All right. So I'm going to show you the first thing I learned as I was doing this, a handy tool. So right now there's no LLMs involved. I'm just going to run this server through the MCP dev tool. And so I'm going to go and I'm going to run MCP dev apps.weather.py. Again, there's no LLMs, there's no inference framework. All this is going to do is this is going to spin up the MCP server just so you can see the server itself. And the folks who built FastMCP, I believe, have made this really nice UI. This should connect to my MCP server, and I can click list prompts. And here we go. You can see that when I list the prompts, I get my weather prompt, and I get it right here. And I get my weather server prompt, and you can see it right here. Likewise, I can go to my tools. I can click list tools. I get my weather tool, and I can run it with a city even. Let's say Austin, and I get that it's sunny. I can run it over here, and it says cloudy. And right now, I want to point out again that there is zero Gemma, there's zero Gemini, there's literally no LLM. This is just a debugging interface for your server just to check that things are running, that you can call the server, that it's responding, just for development. It's actually a really handy tool. I'm really glad they made this. But you now sort of get a sense of what's going on with the server side of MCP.
It's actually a really lovely interface. It's simple enough, but you can do the things you want to do. And I'm still amazed how people can't seem to build proper interfaces these days. But this is actually very, very nice.
It is very nice. I have to say, I really appreciate the MCP folks making this MCP inspector because there's so much happening with MCP and actually so much that happens with LLMs. As came up earlier in the chat, it's really hard to debug LLMs because nothing is deterministic. So with an LLM, so it's really, really nice of them to split the determinism into the server side and give you this nice tool that lets you check that everything deterministic is running as it should.
Yeah, and out of all the labs, I do think Anthropic has a very, very nice design focus around a lot of what they do. And in fact, of course, like everything you do at DeepMind and Google as well. I mean, lots of cool design stuff.
We recognize within Google that these LLMs are, first off, they're fast moving and they're complex. So we just try to figure out the best ways to expose these complexity and give folks the tools they need to run these things. You talked about the agent to agent thing, which I'll talk about at the end. That's another paradigm, and there's another set of tool releases for that. And maybe if later on we could do an agent to agent tutorial, but for now we'll stick with MCP.
Yeah.
But for folks here, given we have 20 minutes left, I just want you to take away right now that all the tooling is on the server side. This By doing this, and which I'll show you later, I happen to define my own server with the weather in it, but you can imagine that other companies are gonna, or other organizations, or other individuals, or even you yourself, maybe you have a bunch of local tools that you want. You can just create your own server and not have to worry about what's happening on the LLM side. You can just say, hey, there's this tool, there's this tool, there's this tool, and I'd like an LLM to be able to see it. That's the point of putting it all on the server side. All right. So now that we have the server side, let's move over to the client side, which is where the actual LLM is. So if I go back to my VS Code, let's go ahead and look at the Gemma client.py here. Now this is initially going to look very complicated. There's a lot of code. The first thing I want to say before we get into it is a lot of it is boilerplate code. A lot of it is things that these days you either just copy and paste from the tutorial, or these days an LLM will just write. So with vibe coding and LLM code completion for these days, you don't have to worry about writing everything yourself. In fact, you could even just copy and paste this client if you'd like. But I want to point out the common elements. The first is going to be the model call. If you look at the notebook, this is exactly the same. If you look at the augmented model call, this is exactly the same. If you look at parse response, this is also exactly the same as the notebook. What's new on the MCP client side is we have a couple more paradigms for initializing the client stack itself, and some things for connecting to the server with SDIO. We have some sort of, again, boilerplate logic for handling all this async stuff. And here's the first thing that you should pay attention to, though. We have this thing called available tools. This is where the client calls the server and says, hey, what are all the tools you have? Now, I'm going to point out, you don't see that we have to explicitly say it has a weather tool. We're deferring to the server for it to provide all the tools that are possible. It's the same thing with the prompts. We can say, hey, list all the prompts you have, and we get all the available prompts on the client side. Now, for this case, I've made this client quite opinionated. I'll talk about why in a second. But I'm saying, hey, I specifically want this client to be the Gemma weather client. And so I'm getting the weather prompt from the server itself. I'm being really specific that, hey, actually, I want to grab the weather prompt. I go through the same augmented model flow that we saw earlier, where I parse the response. If it's a function call, I call it. If it's not a function call, just return the response. And then we have some boilerplate here for the chat loop. So let me go ahead and run this, and then I'll go ahead and look at questions while we have them in the meanwhile. And let me pull up my terminal again.
And while Revin's running that, I do want to say, even Revin mentioning, there's a bunch of boilerplate. This is the type, it's because it's early as well. This is the type of stuff that will be improved upon. We'll develop abstraction layers. And if you're that type of thinker and builder and you want to build some abstraction layers to interact with this stuff more, contribute to MCP, contribute to our communities. So there are just so many different places we can build at the moment.
Yeah, there is a lot actually. So as Hugo said, you can, especially with MCP and all these things now, you can contribute directly if you would like, which is nice. This whole thing is becoming, it's always has been, but it's becoming more and more a partnership. The last thing I want to point out, which is actually an important point, is I'm explicitly telling in this case to connect to the weather server. You could change this to be any server you want. And although I don't show it here, you could provide a list of servers. It doesn't just have to be one-to-one. You could put in 10 MCP servers, and this LLM would then see all the prompts for all the MCP servers. But for now, I'm hard coding it just for the class. So let's go ahead and start this. So I'm going to copy and paste the command because actually it's an easy one, but I just want to make sure I don't mess up live. Let's go ahead and run the Gemma client. CD apps. Okay. Let's go ahead and clear my terminal so everything is, wow, of course. Please say hi to the class. Oh, it's because there is a quote. Of course. Okay. So now I've dropped into my LLM inference framework. So the first thing to say is now the inference framework is actually not directly Ollama. The chat is all being handled by the MCP sort of chat loop that I have down here. So people are asking before about what's supported and what's not. because this is being defined by this MCP client, we're actually not directly using Olama. We're actually processing all this stuff ourselves. So if I type in Q, for instance, this will quit and it should just immediately break out of this chat loop. So let's go ahead and just try that. So you can see that user prompt is Q and it breaks out because I'm handling this now in Python myself. But let's go and say our favorite prompt, say hi to Hugo because Hugo is such a friendly guy. I put a lot of debugging logs in for you folks to see this yourself. So let's see and run this. Okay. As always, oh, I
Oh, I just
am.
remembered, and we can serve this in a front end as well. I forgot to show the Gradio app I built, which we can go back to it at the end, but which does the tool call, and you see the response, and then I've got another output window for the chain of thought behind it.
Okay, so that's
The
actually
tool
pretty nice.
call stuff.
Could use that. Um, let's go ahead and use 4B this time, just to go with it. So people are asking about whether things are deterministic or not. You're seeing live that the Gemma 4B was not very deterministic here. So we'll go ahead. Sorry, Gemma 12B was not deterministic. So let's go ahead and try this again. Say hi to
I mean,
Hugo.
even if reality is deterministic, LLMs are not, right? We've found the loophole in the simulation.
All
Just
right.
quickly, I'm not a tech bro simulation theory dude. I just want to make that very clear, by the way. Like, if people think I know what I look like, I fucking live in Bushwick doing espresso art or something, but um,
In this case, we get the response that we were looking for. So that was a good, again, good eval. If we say hi to Hugo and it comes in with hi to Hugo, all
what's
of
up?
this is just debugging code, just so you can see what's going on. We're gonna try another one. What's the weather in London? So if you've seen this class, you're gonna guess that we're supposed to get the tool call. So let's go ahead and run that tool call. Of course, I get the same error that I did before because I have the same bug that I had before. So let's go ahead and remove the parser. And let's quit out of this so we get the Python code back. What is the weather in London? Okay, and now you're seeing the longer stack. We are seeing that we called and we got the prompt response, and now we're making a tool call with City London. We're processing it. We're getting another prompt that says, "Tell me the weather is cloudy and tell me nicely," and then we get the final response back. If you go through the code, you'll see all those logging statements all over the place. Again, there's a lot of code, so it's hard to scroll through at the moment. But I really, in this case, made this really, really verbose in the logging so you can follow the thought process yourself. That was a really fast introduction to MCP, but that literally is what MCP is.
Mm.
You take the same thing that we showed you in the notebook, but you put it into this client server paradigm, and then you can plug the two of them together. All right. So let me go through the questions before I show you Gemini, because as Hugo talked about, there's a couple nice things with things that are served. And as some of you noticed earlier in the class, there's a couple of niceties when you get the model and the serving framework together. And when you use a bigger model, there's a couple niceties too. So we'll go through a full-size model or a large-size model together. But let's go through questions. Um, do you feel like MCP might go back to OpenAI based spec given the number of auth-related issues MCP has gone over the years? I see Hugo said, real quick, possibly it's early days. I hope MCP is still community-driven and focused. And the other way to answer this is that you're gonna have both as a user, and especially as a developer, you can decide to use the spec and roll your own. Like nobody's stopping you from doing that, or you're gonna have MCP. So we're gonna have both paradigms it seems moving forward. So it's not either or, but I'm really going to say it's both. Mr. Me asks, would the MPC approach have any impact on tokens count? Um, the short answer, there's actually two answers to this question. The very technical answer is no, because the model doesn't see any of the MCP, right? The model just see the prompts that are provided to it. So in that sense, no. But practically speaking, yes, because users using MCP they tend to use a lot of different MCP servers. So where previously with hard coupling, there might only be one or two tools. With MCP, the user decides how many tools they want. And if they plug in a lot of tools, the token count is going to go up. So it's just like a USB device or old computers. Previously, when your computers couldn't plug anything in, um, there weren't that many devices because you could only have the devices that were built in with it. You can imagine a MacBook if it didn't have any USB ports. Um, but these days, when you have a MacBook and you can plug in a USB hub and another USB hub, how many devices can you have? As many as you can plug in through a bunch of different USB hubs. So now it's up to the user how many things they're going to plug in, which affects the number of tools that they have, which affects the number of tokens.
Just make sure our protocols are more like USB and less like Bluetooth.
I hope so. Yes, we're trying for that. Um, let's see. And then, oh, how long is this workshop? We scheduled it for 2 hours to make it easier for you.
Yeah,
We'll go a little bit over, but we're gonna shoot
exactly.
for.
And we did advertise it originally as 3 hours, but then we decided we're covering a lot. And we've got a big week in the courses as well. So
There's a lot. Too many things. So, okay, at the last point, let's go through Gemini and let me talk through the differences with Gemini versus Gemma. So the first thing with Gemini, just to know, just bluntly, Gemini is a much more performant model than the Gemma series. It's 2.0 and especially 2.5 was just came out. These are flagship models from Google. They have the latest and the most capability across pretty much everything. This could be reasoning, this could be function calling, this could be image understanding. They really are the best AI and in many, many different respects. So you're just going to get more horsepower out of Gemini than you will from Gemma. That's just the model layer. The second thing, though, which a lot of you noted earlier in the class and noticed, is that you'll get a serving stack with it. So if you go through the Gemini code, you're going to notice that the way we plug in tools is going to be through this method. So we don't have a system prompt that we need to plug in directly. In the same sense we needed to do with Gemma, we just tell Gemini that you have these tools of this type, and it just knows what's going on there. Similarly, we're going to have a lot more stricter typing, which actually is a very good thing. The stricter typing tells Gemini, especially the API, actually definitely the API, what's a tool call, what's a tool response, what's a tool name. And so throughout here, you're going to see different objects that are explicitly labeled as function call, as tool result, as function response with arguments. And all of this structure gives a more capable model, more indicators, what is what. And through all of this, it's able to give you better responses and more robust responses than a Gemma model, which is running with the framework that we rolled with ourselves. So you get a better model, you get a better framework, and that overall means better performance. You can think of it just like a car. If you built an engine at home and you put it together in a frame that you welded yourself, it's going to be a car. You're going to be able to drive around, but it's much nicer when you get a really powerful engine from a top tier company and you put it into a professionally built automotive chassis or frame. You get a much smoother and reliable driving experience. So if you want to run this yourself, you're going to need to grab a Gemini API key yourself from AI Studio. They're totally free. You get a lot of query capacity with the free API key. You can set your environment. I think I already set this one. I hope I did. So we can run this, but let's try it. Python.
And while Ravin's doing that, I'll just say definitely and I mean the rate limit's actually quite nice. You get a whole bunch of tokens every minute, and you can figure that out yourself. But I just once again big shout out to Ravin and Paige at DeepMind for sponsoring our course and giving all the students $300 in Google Cloud and Gemini credits as well. So it's a bit of shameless multi-sided promotion of everyone involved. So get involved.
Let me go ahead and type in my API key in a secret window so you can't see it.
Dude, that's not YOLO vibes.
Let me go ahead and set the API key. API key equals. All right, let's go ahead and pull this window back. Oh, actually, and then of course I show you the API key, so I'm gonna need to burn that one. So,
that's what I do. I literally don't even care anymore, man. Like I just
every time
I burn it up. Yeah.
All right, so this time we're gonna say hi to Hugo. Okay, of course the API key is not valid, so that's a whole nother thing. So let's leave that one for here. I don't want to debug this live with you, but what I'm gonna say is go ahead.
I can also get another key right now and get it for you while you're talking if you want.
Yeah, sure. Go ahead. We'll give it a shot.
Yeah, I'll do it right now.
While Hugo's doing that, let me answer questions. How much non-deterministic would you accept as a rule of thumb, if any? It's really going to depend on the type of application that you have. So with a weather sort of app, I guess you can deal with a little bit of non-determinism. Like it's not too big of a deal. But if you have a model that needs to be like in a car or something like that, you really want it to be much more. Well, actually, this becomes a really hard. Let me word it a different way. You still want it to be non-deterministic because that's the point of these systems. You don't want, if it was deterministic, you would just use a regular, if else loop from or if else statement from a program, but you want it to be right. It's just like humans. Humans are non-deterministic, but some humans are just better at being right in the right situation than others. Adults famously make better decisions typically than children. Um, so we allow adults to do things like drive cars, and we don't allow children to do things like drive cars, even though both of them are non-deterministic.
And the
Um,
way I commented to Pascal's question about this, but it's really use case specific as well, right? So in serving ads, I'm chill with some more determinism with guardrails for non-offensive content. In medical diagnosis, I'm not. And in fact, in medical diagnosis, maybe you want different types of flexibility around false positives and false negatives. Maybe you accept false negatives. Accept false positives more than false negatives because of the risk associated. So it really has to do with your own risk tolerance, organizational risk tolerance, and what app you're building.
Okay. And while we were doing that, you gave me enough time to stall Hugo. In that, since you saw my API key and I'm gonna get rid of it anyway, here's the model running with the API key. So this is Gemini. Now we're not running everything locally. It's actually going to Google servers and pulling it out. But we get a hello Hugo, just like we did with Gemma. I can say what's the weather in London, like we did before. And to the question earlier, we don't actually hard code in here which function to call. So in the Gemma models, because they're not as smart, just to be frank with you, I have to hard code Gemma to tell it that it should, really should just call the weather function. But you're going to notice that in the Gemini code, we don't tell it to call the weather function anywhere in the code. It's listed nowhere on the client side. There's no opinion again about which tool to call on the client. It just so happens that Gemini 2.0 Flash and 2.5 Flash will also be just as smart, is it figures out that it needs to call the weather function, and that's the one that'll give it the response that it's supposed to grab. And so we get it's cloudy in London because it went ahead to the server, it grabbed that it was cloudy, and it came back and it put it all together. You'll also notice that we don't specify the prompt that Gemini is supposed to use. Gemini is smart enough to figure out what the prompt should be and what the user wants. Now, could we go in and tell Gemini that we want a friendly response or something like that? Yes, we can. Gemini supports system instructions, as you'll see in the API, and you can provide all that stuff if you want. You could augment the response on the client side if you'd like. You could also be clever and put that prompt in from the server side if you want. But with Gemini, we don't have to do all of the hand-holding that we have to do with Gemma. It's really nice in that way. And so that is the bulk of the tutorial. We started all the way locally, where we showed you that a model can be used without any server-side magic and how to run that. But we've gone all the way to what is actually a full-on modern MCP stack. If you wanted to use Gemini in any MCP tool that you want, this is everything you would need to be right at the cutting edge of tool calling with any MCP server that you would like with Gemini 2.0 or Gemini 2.5.
Dude,
And so I
thank
know we're
you.
close to time,
Yeah,
but
I was just going to say thank you so much because I've learned a huge amount in this. I mean, all throughout and creating stuff with you, but in this final section around MCP, I do actually want to share my screen very briefly, and this is a suggestion to
yes.
the excited learner. You can see here. This is in the repo in the same apps directory, and it's called like agent demo Gemma or something like that. And I'll just say, "Hey Gemma, what's up? What's the weather in San Francisco today?" Okay, so I'm submitting this, and we're gonna get the final response, and then it will say what the tool calls are doing underneath. So, once again, great. Ah, this is really weird. Well, this isn't what I wanted. So this is a total mess up. I'm going to submit it again. We can see non-determinism in action, perhaps. But the
That
point got an error out. Um, okay. Wow. Weird. Great. We got several results, including an error. Three different results, including an error. Okay, let's put it nicely. Why are you even, why are we putting it nicely? It's a wonderfully cloudy day in San Francisco. It's a bit misty and soft with a lovely gentle feel in the air. Would you like me to describe? I mean, this is Mark Twain all over again. It with a slightly different tone, like perhaps a bit more poetic. No thanks. Tool call detected, city San Francisco, weather cloudy. You can have a look how I decided to get it to tell me what was happening under the hood. The reason I wanted to demo this now is Ravin showed some great examples of how you get logs out when you're doing all your MCP stuff, and you could build a little app like this, which shows you all the logs in line as you're building in real time. So I very much encourage you all to play around with such tools. And as we said earlier, it's such an exciting time to build and decide what you want to do. It's challenging to not get lost in the decision making though. So you have to make a decision as well. I want to say that there are days where I do so many things, I end up having done nothing. So just remember, don't get lost in all the choices.
there's yeah, Hugo points out. I think I want to reinforce that again. There's a lot happening, and it's being confusing if you're trying to understand it all. But the best way is just go in and try something. Like just try doing things, and you're gonna learn much faster and much more concretely than if you try and read every single blog post out there. Um, so Hugo, I think we're at time, but do you want to stay on 10 more minutes and we can just answer everybody's questions? Is that
Absolutely. I'd love that. But before I know people will have to leave because it is time. So I just want to thank everyone, not only for joining, but for engaging so much, asking interesting questions, pushing us. We love doing this type of stuff. And as I said, like you can get decision paralysis and not figure out where to focus in the space. It's actually sessions like this that help me focus as well. It may seem counterintuitive. I do think at the moment, I used to joke that we used to live in a complex environment with respect to machine learning and data science techniques, tools, methodologies. Now I think we live in a chaotic environment for some, and it's not complex anymore. It's very tough to know what will be happening tomorrow, let alone today. So we all need to be exploring more and talking with people and building communities. So that's why I love that all of you have turned up, and I'm really excited to see you at our next sessions as well.
Yes, actually, yeah, thank you everybody. I think um as fun as the AI is, I still am rooting for humanity, and I still get more excitement from interacting with people. So appreciate you all showing up and being a part of this as individuals and bringing your perspective and asking questions. So genuinely, thank you.
So, look, Okigan had a great question, which we can't get too in the weeds with now. Funnily, in the course this week, we're doing a lot of this type of thing and have the past couple of weeks. But the question is, how do you evaluate prompt changes in an automated CI/CD fashion? So, some good news is if you're doing something in a GitHub repo yourself, you can get CI/CD working straight away, right? So you can and get your evals working with CI/CD and automate essentially whatever you want then. So how do you iterate on prompts and where do you store them, right? So that's really the question. And the truth is, I've seen two patterns, right? I've seen people adopt tools. First, OpenTelemetry is sick. Use OpenTelemetry. Sick means good in Australia, by the way. If you want something a bit like built on top of it or heavier hitting, Arise Phoenix, Langsmith, Brain Trust, these are all tools so I'm laughing because when Raven and I were preparing this earlier today, I was like, dude, these platforms are killing me, man. They are wonderful tools in a lot of ways, but they don't solve all the problems we need to solve at the moment. And they also really push us towards a world of automated evaluation and not developing ground truth data sets. So they actually make that particularly tough at the moment, bizarrely. But I understand the tragedy of the commons, the venture-backed tragedy of the commons is forcing these frameworks to do that type of thing. So what I've seen is people adopt these frameworks, then after seeing failure mode, failure mode, failure mode, cost, they'll start to hand roll things. And that's the other motion I've seen is people literally hand rolling custom tools, and you can do it with AI assistants these days to version prompts, to view them, even hand rolled like custom JSON viewers and that type of stuff, where you can get prompt, response, tool call, whatever, and you can label in the browser, all of these types of things. So it's a far from solved question, but those are the approaches I've seen. And I wonder, in your work on Notebook LM in particular, what type of things have you thought about with respect to versioning prompts? Mr. Me mentioned Firebase as well. Yeah, I mean, there's a whole list, right?
So I think the first thing I want to point out, which keeps coming up, especially now this vibe coding thing, is even though we're in this land where LLMs are doing a lot of reasoning for us, like you keep hearing how AI is going to replace programmers, this and that. At the time being, actually being a really strong programmer and understanding CI/CD, understanding test, like these are very helpful skills. Like all the skills you were told to learn before AI are super helpful when you're building AI applications, because not only do you have all the things you need to know to build a program, like Gradio and environments and everything that Hugo just showed us, you also now need to deal with the non-determinism of the model, which just complicates the whole thing. Um, so on my side, within Google, as you can imagine, we have a lot of CI/CD tools that we use. They're the same ones we use for Gmail and Workspace and all the things that we had before Gemini. And for myself locally, I tend to just have like an eval harness and PyTest. In the open source stack, I use with PyMC and Arby's, and I just run them every now and then to see how far the things have drifted. So it's still looking very much like, let's call it software 1.0 CI/CD. It is not any extra new magic. Um, there are a lot of, like Hugo said, there's a lot of now different platforms that are coming out that have observability or are built specifically for LLMs. I just was at Data Council, where there were a couple folks talking about how they're building the logging for the AI age and things like that. And I think there's a lot of good things in those vendors, as Hugo has mentioned. But if you don't understand what's happening, then you're going to get stuck on some rough edges. So learn the programming fundamentals and then try out the new tools if you'd like.
Yeah, and it isn't only if you don't understand things. Like the platforms aren't comprehensive. So I'm not going to name who they were, but these are the screenshots I messaged you today, Ravin. I was working in one and doing hand annotations with respect to agent tool calls in their platform. And as it turns out, their SDK, there's literally no way to get the annotations. You can get everything. You can do like infinite LLM as judges and shit like that. Part of my language. Oh no, that's going to hurt YouTube. But yeah, you can do all of that, but I couldn't get the annotations out. So, and they've raised a GitHub issue about it. Like, this is something I need in my workflow, right? So not only are there rough edges, but there may be things that you cannot do with them that will hurt you.
Yeah. So my advice, just as Hugo said, is even though AI is all the cool things, like girl rewatch a lot of Hugo's stuff from the last decade, the 2010s, because all that stuff that I remember him and others talking about at PyData conferences in like 2018, 2019, 2020, like a lot of that is still actually still more relevant than ever, I would say.
Totally.
Let's go through. There's a question I saw in the chat, and I'll answer it on YouTube as well. Do you ever see an LM deciding what server to connect to? Not sure if it's a legit question or if there's any reason to do so. Just trying to understand the limits of MCP. So I have not myself seen an implementation of an LM deciding what server to connect to. But that being said, it is not that hard to do so. I mean, if we had another hour, we could live code this together. But you would just define another function that says, call MCP server selection tool, and then it could connect to that server and then grab new functions. Like these things are just, as the meme said, are just while loops or for loops all the way down. So it's possible, and I would actually even say if you're really ambitious, go ahead and try it. Like grab a bunch of MCP servers, and I would suggest using Gemini, not Gemma, because I will tell you that Gemini is more likely to get it right. Use Gemini and see whether you can dynamically connect to MCP servers. It'd actually be a really fun experiment.
Yeah, and I'd also love to see people experiment with like Gemma 3, then Gemini, and see what works best for their purposes. And for a lot of use cases, you don't need like the biggest model, right?
Yeah, I think that's true. I should say to be explicit, like I'm easily able to say these things because I work with Gemini and Gemma each day, so I get and understanding of all the capabilities. But for folks that are not with models, working with models each day, just as Hugo said, don't feel like you have to always start with a huge model like Gemini or something like that. Like try it out with a Gemma or other similarly local or smaller size model. And if you're not getting what you need, then step up or go the other way around. But I hope as you're getting the vibe, just try something and go do it, and you're gonna learn quickly what works and what doesn't.
Well, on that note, I think it's a great time to wrap up. I would love everyone to chat more in the Discord community. As like this week, next week, if something comes up, if something piqued your interest here, or you built something based on this workshop, please do let us know. Because this space is one, I find it wonderful and filled with so many exciting ideas. And we have wonderful people like Ravin coming and speaking and teaching as well. And that brings me to my final gratitude. Thank you so much, Ravin, for your ongoing collaborations and just I have a ball teaching with you and chatting with you, man. So big ups to you, man.
Thanks, Hugo.
Awesome. All right, everyone. Well, see you on Discord and can't wait to see what you build next.